Welcome back. Here we are in the second part of the temperature lesson. We're going to talk about mercury rising. Mercury used to be used in thermometers, and it has been found out that it's a poison. So nowadays we don't use glass thermometers filled with mercury. Mercury is actually um, watched very closely. OSHA pays attention. And so now what we use is glass thermometers with a red alcohol water mixture. And so mercurizing is just a pun on a thermometer, which is an instrument used to measure temperature. I swear, PowerPoint. So temperature is a measure of the average kinetic energy of all the particles in an object. So we're going to learn the difference between temperature and heat. Person without a science background isn't going to see the difference between the two words, but in science they do have different meanings. And so we can use temperature to help us watch phenomenon. And so here the water temperature is measured from satellites, and we can see that the warmer water comes down the coast here, and then it does some mixing with the colder water that's here. And so we can use temperature to help us measure and watch phenomenon. We go back to this graphic to remember that the kinetic theory of matter states that all matter is moving in some shape, way, form, or fashion. So remember, this was an example of a solid at a low, medium, and high temperature. And while we're here, I'd want to take a minute and go and look at an interactive. It's an interactive that you can get to if you want to. PHET is a website that has a lot of science interactives. So if you're just interested in science, you can go and look at some of their interactives and do everything from photosynthesis to wave theory. And so here we have water. Water is a molecule made up of two hydrogens and one oxygen. And we can change the heat that this water is under. And so right now you can see that the water molecules are vibrating, that they're close together. So I would say this is what, a solid, liquid, or gas. I would call it a liquid. If we look at water as a solid, it's going to be in a more rigid pattern. We actually should look at a gas, but we'll do that in a little bit. And then water as a gas. So if we go back to it being a solid and we add heat, water is actually different than other molecules in that it has special properties. Here you can see the molecules are vibrating faster, that they're sliding past each other, and they're free to move around. But you can see that their movement is faster than when it was a solid. So let's make it cold again. You have to give it a couple of seconds. You can see that the molecules are slowing down, but they are still vibrating. And they spread out into that lattice form that makes water unique. Okay, let's look at neon. For neon to be a solid, it has to be negative 259 degrees Celsius. I don't want to be around if it's ever that cold. So here you can see that the atoms are packed here close together, but they're still moving, they're still vibrating. So let's add some heat. And you can see that they bust out of this general area here where it's a liquid and start escaping into the gas. If we reduce the heat, you ought to see that the atoms slow down. Hopefully we don't have to wait a long time for them to slow down enough. And then here we are back to this solid state. Okay, let's look at oxygen. Oxygen here is as a molecule, two oxygens bonded together. Here is a solid. We're at negative 246 degrees Celsius. Again, don't want to be around when it's that cold. So let's make it colder. Notice how that the molecules are vibrating less and they are seems to be not moving as much. Then we go back to the negative 272. And then let's add some heat. So temperature is if we added up the kinetic energy of each one of those molecules, that is what temperature would be. It's a lot of math. We don't want to do it. Okay, back to the PowerPoint. So temperature is a measure of the kinetic energy in the particles of an object. So when you take your temperature, you're taking the average kinetic energy of everything that's inside of you. So on page 134, question number 7, ask you, does a substance temperature change when the average kinetic energy of its particle increases or when it decreases? So yes, this is a yes or no question, but notice it says explain. So make sure to explain your answer. So here we have an example of hot water, and we put the spoon in the hot water. And this temperature is being spread to the spoon, and that's going to be a tie to our next part of the lesson. Number 8 says to produce a story about someone who travels to an extreme temperature, and there's a handout for this. And so pick up the handout, and that will give you more space to write your story. Here's what the handout looks like. And then number 9 wants you to look at these 3 thermometers. And there's 3 ways to measure temperature. We have the Kelvin scale, which is for very extreme high temperatures, like the temperature inside of a star. Then we have the Fahrenheit scale, which is what we're used to. It's 80 degrees outside. And then we have the Celsius scale, which is the scale that is used mostly in science. There's this thing called absolute zero. It is a place where you can compare all 3 scales. And so you can see that they put certain marks on these scales for you. So we have room temperature is 20 degrees Celsius, 68 degrees Fahrenheit, and 293 degrees Kelvin. And then we have when water freezes and when water boils. So when water boils and water freezes are important points to burn in your brain, I guess, because you'll have to be using those through science as you go along through your high school career. So it's wanting you to mark positions on each of the 3 things. And so this one wants you to take 80 degrees Fahrenheit. So you'd find where it was here in Fahrenheit. So here you have 68 and here you have 98.6. So where would you put 80 between those 2 points? And then mark it on the other 2 scales also. So if it's here, where would it be on here and where would it be on here? So just a graphic to help you look at the three skills together. Another graphic. And then we get to the visual summary. So the visual summary wants you to start out by filling in the blanks with the correct words here and here. And then it wants you to make some inferences. And remember, an inference is a judgment you make based on prior knowledge or data that you have. And it wants you to talk about when a puddle is frozen and the kinetic energy in that puddle. Then you end up with the lesson review.